All right. So, one little thing I wanted to show you guys here, difference of squares. This is one other factoring method that I didn't get to yesterday. Okay. And that is this. A squared minus b squared.
Equals c squared?
Nope. That's a squared plus b squared equals c squared. And that's for right triangle. Right? Now, if we have a squared minus b squared, so something squared minus something squared, you can see why we call this thing a difference of squares. Difference means what operation?
Division.
Subtraction, right? Okay, so there it is, the difference. And then of squared, right? A is a perfect square. A squared is perfect square. B squared is perfect square. So if you see a difference, a subtraction of two perfect squares, then you know that you could potentially factor using a difference of squares. And this is the formula here. It'll be a minus b times a plus b. Okay. So let's take a look at some examples here. Let's try like x squared minus 9. Okay, as an example. Okay. Is x squared a perfect square? Is x squared a perfect square? Something squared, right? So that's a perfect square. Is 9 a perfect square?
Yes.
Yes, it's 3 squared, right? So, if in fact, you can kind of think of it as like x squared minus 3 squared, like that if you wanted to, right? And so you can see here, right, if we try to use our format that we've got right here, okay, we try and use our difference of squares format, you can see that the x corresponds to what letter up here?
A.
It corresponds to the a, right? X is like our a. And then the 3 is like the what?
It's like the B.
Like b, exactly right. Okay. So then we can just use our little, formula here if we want to factor this thing. So if x is a and 3 is b, then a minus b in our case would be what minus what? It would be x minus 3, right? Because, and again, x is like the a, and then b is like the 3. So it would be like a minus, there's our a minus b right there. And then times, and then we're going to do a plus b. Okay. So, in this case, right, for a plus b, what will we write? What's our a, what's our b?
X plus 3.
X plus 3, exactly right. And there it is back. Okay. There it is.
You ignore the minus sign.
Say one more time, sorry?
You ignore the minus sign in front of the 3.
Correct. Because you can see the format for difference of squares is you leave the minus sign kind of between the two terms, but you don't like bring it in with a 9 or anything like that. You leave it separate there. Okay? So there it is. All right? That's an example of a difference of squares. Now, you're going to be like, Mr. Whitmire, do I really have to learn one more technique? Okay? Can't I just already do this? And the answer is yes. All right? This is also a quadratic equation, isn't it? And we know how to factor quadratic equations either by guessing and checking, or you guys could use your AC method here. The AC method works for this, and it's similar in sense to what I showed you over here, but we'll do it on the video too, so you guys will have that. Let's also try it. So we'll do AC method as well. Over here on the side. So we did difference of squares here. Okay, and I'll do AC method here. Okay. So what is our A in this quadratic? What's A? What's our lead coefficient here? 1. Okay. So it's going to be 1 times what's our C term? What's our constant term? It's going to be negative 9. All right, negative 9. So we get negative 9. Excuse me. And so we're looking for two numbers that multiply to negative 9 and add to What's our b term here? What is our middle term? 0, right? So we need two numbers that multiply negative 9, add to make 0. Negative 3, positive 3, exactly right. Okay, so negative 3, positive 3. So we'll take our x squared minus 9, and we'll put that minus 3x plus 3x in between there, like that. Okay, again, those two numbers, right? We split up that middle term that didn't exist. Okay, right there. And then we can group the first two and group the second two. From that first group, right, they both have an x we can take out, so we'll have an x minus 3 left over. And from the second group, what can we take out from that second group? The 3. And so we'll have x minus 3. Okay? And so we have the same leftovers, right? You see that there. So we'll have x minus 3 and then x plus 3 is what's left behind. And look at that. It's the exact same thing. Okay? So do you need to know difference of squares? No. You can just use AC method if you want. Okay? You can just use AC method there if you want.
AC is probably actually easier to do.
I would say, right, because it's more, you can generally apply it to a lot of different situations. You don't need to, stop, basically. Okay? So let's try a few more here. All right. Let's do 16x to the 4th.
I got one no name.
Oh, thank you. Minus 1.
Do you want me to recycle the rest?
Oh, yes. All right, please. Thank you, Rohan. Anyone want to claim this, the no name here? Whose handwriting is this?
Chris? It's not my handwriting.
Is that you, Christian?
What?
Is that your warm-up?
Oh, yeah.
Okay. Thank you, Rohan. Will you mind running over there and recycling that, and I'll just put the. You can recycle that. I'll put the score down.
Okay.
If you just want to run over the bin for me, please. Sorry. Thank you. Okay. Thanks again, Rohan. Appreciate it.
No problem.
Okie dokie. So, let's look at this next one here. Is this a difference of squares? Well, let's at least look at the 1, right? Is 1 a perfect square?
Yes.
It is, right? Okay, 1 times 1 is 1. Is 16 a perfect square? It's 4 times 4, right? 4 times 4. Is x to the 4th a perfect square? So the question we need to ask then is what times itself gives us x to the 4th? So what can we multiply times itself to give x to the 4th?
X squared.
X squared, yes. So actually, this is a difference of squares. Okay, this is a difference of squares. The 16, okay, is a perfect square of 4. The x to the 4th is a perfect square of x squared, and 1 is a perfect square. So in other words, let me break it down here for you. These are our two perfect squares. Okay, like that. Okay, and again, I'll show this two different ways, right? I'll show you with the AC method, and I'll show you with the difference of squares too. Okay. So in this case, right, since 16x to the 4th is really 4x squared quantity squared, right? This is our A. Okay? And then 1 is our B. So let's see, I don't want to lose the difference of squares up there if we can get up there. So we'll factor using this method, right? So, okay, we can see then that if we have A squared, so 4x squared squared, minus B squared, 1 squared, okay? We can factor to this. So it'll be A minus B. So in our case, if we want to write A minus B, what will that be for this particular case? What will I write? What is A minus B in this problem? So 4x squared, and then minus what? The B is 1. Okay? And then for the other one, we'll have A plus B, so it'll just be 4x squared
Plus 1.
plus 1. Yep, and there it is. Okay, again, we're just factoring. I should put like the direction up there to factor. Okay. Now, one thing though here, this is another difference. And is 1 a perfect square?
Yes.
Yes, and is 4x squared a perfect square?
Yeah.
Yes, so this factors a little bit further, okay? And I'll just go ahead and factor it out for us right there. It's going to be 2x minus 1, 2x plus 1. And then that 4x squared plus 1, is this a difference of squares? Is this one a difference of squares? Is it a difference? No, it's a sum, right? And notice I did not give you guys a sum of squares formula. There isn't one. Okay, there is not one. You can try if you want to factor it using like the AC method or something like that. But you know, if you do AC, 4 times 1, that's 8 times C, right? 4 times 1 is 4. And you need two numbers that multiply to make 4 but add to make 0. And there's no two numbers that multiply to a positive 4 and add to make 0. So this does not factor any further. We just bring that one down. Okay. So again, always keep an eye out, right? Problems may factor more than once. Problems may factor more than once. Okay, so you might need to, you know, continue the factoring. Okay, might need to do that. All right, let me do one more here with you, and then I'll have you guys try two on your own here. Okay? Try one more. All right, x to the fourth minus 4x squared plus 4. Okay, so is this a difference of squares? Not really. We have 3 terms, right? For our difference of squares, we really only need we need 2 terms, right? Like that. So I mean, if we didn't have that plus 4, then you'd have a difference of squares here. You know, that would be a difference of squares. But the plus 4 doesn't make it a difference of squares, okay? But if you'll notice, it is like in a quadratic kind of form, right? We have we have 3 terms here, and so we can actually use our AC method even for something like this, right? Believe it or not, we can use our AC method for something like this. So what's the A in this situation? What's the lead coefficient? 1, right there, 1. Okay. What's our C? 4. Okay, so what is 4? 4. We need 2 numbers that multiply to positive 4, but add to make, what's our middle term here? Negative 4. So 2 numbers that multiply to positive 4, but add to make negative 4. What are those going to be? There are 2 numbers that do it. So positive 2 and positive 2 would multiply to positive 4, but they would add to a positive 4. We need to multiply to a positive 4, but add to a negative 4. So 2 and 2 won't work.
Negative 2.
There you go. Negative 2 and negative 2. You got it. Okay, so we'll break up that middle term. So it'll be minus 2x squared plus the 4. Okay, group the first 2, group the second 2. From that first group, what can we take out? An x squared. And we'll be left with x squared minus 2. From that second group, what can we take out? A negative 2. And we'll be left with x squared minus 2 like that. Okay. Oh, x squared plus. No, never mind. Okay. Factor out the x squared minus 2. And we're left with an x squared minus 2. Okay, so you can leave it like this if you want to. Actually, let me stop that. Okay. This is a difference, but are these both perfect squares? Is 2 a perfect square? No. So we can't factor that any further, right? So that we can stop here. We can stop here at this one, so we don't have to factor it further. So you could stop here. Or you could also write, since you're multiplying something by itself, we could also write x squared minus 2 quantity squared, right? Because when you multiply something by itself, that's just like squaring it. So this is also okay too. All right, let me give you guys 2 to try. I'll give you 2 to try here. All right, so try, and then we'll look at division. We'll move on from factoring to division. Here's one for you to try that. Okay. So factor the following. One. We'll do x squared minus 25. And 2. We'll do n to the 4th minus 11n squared minus 16. So give those two a try. And I'll come around and help if you need some help. Okay. You got like 30 more seconds here. We'll go over these. Any questions on anything so far? All right, let's go to Hannah. Were you able to factor number one?
No, not really.
Okay. Did you have any idea about what you maybe wanted to try to do? Did you recognize this as something we had seen earlier or anything? Or okay. So I mean, if we look at this, for example, we can see it's a quadratic, right? Our highest power is x squared there. Okay, so we could use the AC method here. If it factors, the AC method will work for us. Okay. So what is our A in this problem?
X squared.
Yeah, so what's the number in front of it?
1.
A 1, right? Okay, so it'll be 1 times, what's our C? The negative 25, And that leaves the question of what's our B? There isn't one, right? So what number would that be? If there's, well, typically, right. But there's like the B is not there at all, so if there's no B's, it's 0.
Okay.
So we're looking for two numbers then, Hannah, that multiply to make negative 25, but add to make 0, that missing. In fact, let me just write that here. X squared plus 0x minus 25, right? That's the same thing. There we go. Okay, so we need two numbers that multiply to negative 25, but add to make that middle term 0. So, think of what two numbers that multiply to make 25? Okay, right. If we need a negative 25, one will be positive, one will be negative, right?
Yeah.
And what's 5 plus negative 5? There it is. You got it right there. That was the answer. Okay, so x squared plus 5x minus 5x minus 25, right? We can break up that middle term there. Group the first two, group the second two, right? From this group, Hannah, what can we take out?
An X.
Yeah, an x. You got it. And we're left with x plus 5. From this group, Hannah, what can we take out? Yeah, depending on x. Well, numbers. These are both divisible by what number? 1. That's true. There's something bigger though. What can divide a negative 5 and divide a negative 25 evenly? Yeah, 5. Take out, and we're going to take out negative 5. So negative 5, which leaves, if I divide negative 5x by negative 5, I'm left with just the x, or 1x. And then negative 25 divided by negative 5 is positive 5, right? And you see, hey, look at that. Same leftovers, so we can pull those out. X plus 5, factor those out, and we're left with an x minus 5. And there's our final answer. Okay. So you didn't need to use difference of squares there again. You could absolutely use just the AC method. Okay. Same thing is true for number 2. Thank you, Hannah. All right, let's go to Michael M. Michael M., were you able to factor number 2?
Yeah.
Yes. What did you get? Okay, sorry, I see what you're doing. My apologies. Yes. Let me go down to here then. I see what you're saying. So end of the fourth, you said minus 15n squared plus 4n squared minus 60, like that, right? That was your next line. Okay, very good. So you guys can see what Michael's doing here. He's using the AC method, okay? 1 times negative 60 is negative 60, and he looked for two numbers that multiplied to make that negative 60, but add to make negative 11. He identified that as negative 15 and the positive 4 there. So he broke up the middle term using those two numbers that he found. So again, he's just doing AC method here. Okay, sorry. First group, what can we take out there, Michael? N squared. And we're left with an n squared minus 15. In the second group, what can we take out? Yep, and it's n squared minus 15 again. And then we have those n squared minus 15s we can take out. Leaving behind, n squared plus 4. Okay? Now, both of these are quadratics, so we could use AC again, potentially, but it's not going to work. For example, if we do 1 times negative 15, we get negative 15. Are there two numbers that multiply to make negative 15, but add to make 0? No, right? You got 3 and negative 5, or negative 3 and positive 5, or positive 3 and negative 5. It's not going to work. So that does not factor further. Same thing here. There's no two numbers that multiply to make a positive 4 and add to make 0. So this is as far as we can go. We're done. That's as far as the factor is.
2 times 8.
Okay.
Wait, you said that would factor to multiply to be 4 and add to be 0?
Correct.
Negative. Oh.
Right, see? Yeah. They have to be the same sign, so they won't add to make 0. All right, let's change gears a little bit then. We're going to look at long division, okay? So we're going to get out of the fact and there. We're going to look at long division.
I hate long division.
I know, but I would argue...
It's like, because my parents would give me, like, what are you doing? When they would be like, it's just this. Like, I would go through at each individual step to divide something.
I'll review the algorithm with you, and then we'll do it for real with polynomials. Okay? You hate long division?
Yes.
You only hate it because you don't know it. Once you get to know it, he's an all right guy.
Yeah.
He's all right.
I thought we were done with it.
It's like fractions. People don't like fractions because they don't know fractions.
Wasn't long division in like 5th grade?
Yeah. This stuff was like 5th grade.
Yes, long division was probably 5th grade. For me, I think I remember learning it first in 4th grade. I was sick that day, and like I felt like I was always behind because I never, felt like I really understood long
Because
division.
it was a very traumatic time.
It was a traumatic time. That teacher also made me cry in class too. We were doing one of those like timed math tests. Did you guys have to do those timed math tests with like the little bubbles?
Yeah.
And like I forget even like what the circumstances were. I think like I just got frustrated with it. I think to the point of tears. And then she like decided to like call me out in front of the entire class. Mrs. Catherine, you jerk. Anyway, she was old and mean too, but oh well. Well past the year, she should probably be teaching children, kind of thing.
That's not first grade for you.
What's that?
Always the old teacher.
That's like 50% of my teachers.
So
I think the only like old teacher that's really nice
I don't want to
is
be
Miss Mel.
dead.
Miss Mel is she is a peach. She's a gem. Yeah, she really is. She's great. If you've never experienced or had interact with Miss Mel, I would encourage you to.
I've interacted with her in the study cat.
Yeah.
Yeah, that smells amazing.
So, all right. Let's take a look here then, right? We've got 7, okay, and we're dividing 472 by that 7. So you guys might remember, right, that 472, this thing is called the dividend. This 7 is called the divisor. So the number that we're dividing by always goes on the outside of our little symbol here, and then the thing we are dividing goes inside a little symbol here, okay? And so the idea of division, okay, is that we are, so if you remember multiplication, when you guys first learned multiplication, you did stuff like this. You were like 3 plus 3 plus 3 plus 3. And you're like, that's 12. Okay? But it's also 3 how many times?
4 times.
4 times. And so it's 3 times 4, which is also 12, right? So when you first learned multiplication, you may have learned it as like repeated addition, right? You just repeatedly add things together, the same thing together, and it's the same as multiplication. That's where that word times comes from, right? Why do we use times sometimes when we're describing multiplication? It's because it's 3 4 times, or 4 times 3, kind of thing, gives us 12. Okay? So for division, we won't be repeatedly adding. We're going to be repeatedly what?
Dividing.
Subtracting, repeatedly subtracting. Okay? So we're trying to subtract, quantity, like multiples of the 7 away from this and figure out how many of those, multiples of 7 kind of fit in
You
this
can't
number.
take any out of 4, so it's a 0.
So exactly. So we start with the very first number here, 4. And we ask ourselves, what times 7 can give us 4 or something close to 4? And the answer is
0.
there's 0, right? 0. So you can put a 0 here if you want, or like a little x or something like that. You just basically leave this blank, though, and since it doesn't work for the 4.
No,
We
it's
then
47.
consider the 47, right? And how many times does 7 go into 47?
Well, not even.
It doesn't go evenly, right? So what's the closest we can get?
30.
So if we do 8 times 7 would be 56. That would be too big.
7 times 5.
7 times 5 would work. It'd be 35, but there's a bigger one.
42.
6. It's 6. Yeah, 6. Okay? So 6 times 7 is 42. Okay, so we multiply those two numbers together, and then we're going to subtract 6 times 7 from that. Okay? And so when we subtract there, what do we end up with?
With 5.
A 5, right? And that remainder, and we're not done yet, right? But that amount, that clues us in that we chose correctly with the 6. If this 5 was something that was bigger than 7, right, that means we should increase our number by 1, okay, and then go from there kind of thing. But since our remainder is smaller than 7, we can keep going. All right, we drop down the 2. Remember that? Now you drop down the 2.
That's 7 times 7.
And so, right, the next thing, what times 7 can get us close to 52? It's 7, right? 7 times 7 is 49. We subtract the 49 there, and we're going to get 3.
No,
Okay?
we add a 0.
Yeah, so, we'll get to that. Yeah, okay. So at this point, you have some decisions to make about what to do. Bobby said to add a 0 onto this number. You put a decimal point in that 0.
Good morning, Bear. Pardon the interruption this morning to your classes. First, I'm happy to see so many of your smiling faces today. Thank you
Oh,
for
Miss
taking
Smith.
the time to school.
Listen, please.
Dr. Solomon, the Maryland State Superintendent of Schools, shared in a press conference yesterday afternoon that schools will be closed on Monday, March 16th through Friday, March 27th. The purpose of this closure is to slow the spread of COVID-19 through social isolation, which will limit the spread of germs. During this closure, all SCPS extracurricular activities are canceled, including all athletics, play practice, and any other after-school events. Please take your belongings home with you today, including your Chromebook and charger, and any belongings that may be in a locker, a regular locker, or a cadet locker. Teachers, this is important. Please communicate with each of your classes today your communication plan and how you will connect with them if learning expectations move to online learning. Let
So
them know
if-
how you will get that message to them, preferably
So it's
through
up to
Schoology or
you.
Google Classroom. Students,
It's not up to
if you completed the survey after 7:55, please complete it again because one of our friends thought they were funny and really liked Fortnite. Please stay tuned for additional communications information. I will continue to share information as it becomes available and ensure I will receive many updates throughout the day. Thank you again for your patience and flexibility during this time. Bye. Have a great day. Thank you.
I guess
How does that affect the...
somebody spammed maybe the responses or something like that.
They probably did, yeah.
But I feel like, can't you like...
Filter them out or something.
No, they just don't want to have to deal with filtering it, so they're just going to make us all do it again.
Maybe.
So we
That's what
got
they did the
Oh
survey
my gosh.
again.
All right. Well.
Just don't do the survey. Really?
All right. So then, if you guys would please go back to Schoology and take the survey. Okay. Yes, I guess that's what they said to do. Okay. Oh wait. After what time it said?
7:55.
Oh, okay.
You know, if you did it after...
Oh, you did it after 7:55.
We didn't do it after 7:55. We did it before.
We did it
Also,
before
base
7.
can actually
Okay,
to, like,
then you're okay.
the
Never
last
mind.
entry.
All right, so this is how you do long division, right? So back to what we were talking about, okay? This is really powerful, right? This is like how you guys can like do decimal calculations without needing calculators and stuff like that. For example, at this point you have two options, right? With this remainder, okay, we're out of numbers here, right? So option 1 is to say this is our remainder of 3, right? And so then the answer of 472 divided by 7 is 67 and 3/7. Okay, like that. The remainder you put over the divisor, and that's your final answer if you wanted to. You could stop right there and say, okay, 67 and 3/7. That's where we get that mixed number from, okay? If you wanted to try and find the decimal, what you do is what Bobby said. You can add a decimal point right here, put a 0, because 472 is the same as 472.0. We'll put a decimal point right there with a 67 as well, and then we'll just continue by dropping the 0 down, and then you would ask yourself, what times 7 gets you close to 30, which would be, in this case, 4.
7
Yeah.
times 4.
Yeah, sometimes 4. You get 28. So you subtract, you get 2, you add a 0, and then you drop the 0 down, and so then you continue. You continue until
you get it where it perfectly goes.
yeah, where it either stops or it repeats regularly. Right. And in this case, you're going to get a repeating one.
No?
Yeah. 3/7 repeats. 3/7 repeats. It'll repeat. It's going to repeat. It's going to take a long time to repeat, but it will repeat. Okay. So it's dot dot dot. I'm not going to do that because what we'll be doing is this, where once we get to a remainder, we'll take the remainder and put it over our divisor and get a final answer here. So let me show you how we're going to be using this in polynomials. Okay. Bless you. Bless you. Okay. So we're going to divide this polynomial by x minus 2. We'll be doing that in a future lesson. I was going to say Monday, but I don't know. You know, that'll be in the next lesson, Lindsay. We'll be doing that. You said you don't like that
No,
because it doesn't make sense to you or something, or
no, it's just.
that's not okay. We will be doing it. Yes, synthetic division is what that's called. Yeah. Okay. So again, we're dividing by x minus 2, so that's what goes out front. And what are we dividing? It's this polynomial right here, so that goes in here. Okay? Okay? When you do polynomial division, okay, you want it to be in standard form. Okay, and you want to use 0 for missing terms. Okay, so like that's not a problem here. So when we go to do our long division, you want to make sure that you are in standard form, which we are, right? This one's also in standard form. And you want to also make sure to use zeros for missing terms. Now we are not missing any terms here, right? It goes x cubed, then there's x squared, then there's x, then there's our number, right? So no missing terms here. Also there's no missing terms with our divisor, right? So we can go ahead and do this. All right. And we're going to ask ourselves the same kind of question here. We got our lead of x. We're not going to worry about the minus 2. Just the x is going to guide us here. And then we're going to consider the lead here, x cubed. So what times x will give us x cubed here? What times x gives you x cubed? X squared. So we're going to put an x squared right there. Okay? Then you'll do x squared times x, which is x to the third. And we'll do x squared times minus 2, so minus 2x squared. Notice that my cubes line up, my x squareds line up. And that should work if you correctly set things up. Okay? What are we supposed to do with this thing? Subtract it, right? Just like we did in the earlier problem, right? We're going to subtract the quantity. Okay? So there's where our polynomial subtraction's coming in, right? I would encourage you, though, instead of subtracting, to add and then make these opposites. And that's what I'm going to use red there to show that. Okay, so it stands out a little bit. Okay? What's x cubed plus negative x cubed? what happens here? They cancel, right? And what's 5 plus 2? Plus 2, yeah. 7. So 7x squared. Okay? There's our remainder. What should I now do? Bring down that minus 7x. You don't have to draw the arrow there. I'm just drawing it just so you can kind of see where it's coming from. You know, it's not from nowhere. Okay? So now this is our new problem here. We want to see what times x gives us 7x squared. So what do we multiply x with to get 7x squared? 7x. Yeah. So 7x times x, 7x squared. 7x times minus 2, minus 14x. And again, we will subtract that quantity. But again, I don't like subtracting polynomials. I'm going to change it to add the opposite. Okay, it's slow going, but I won't give you guys like a million of these to do, right? Because it can take a little while. But you should be able to do it for sure. The ones I do get you, right? They're actors. So 7x squared is cancel. We have a negative 7 plus 14, so that's positive 7x, and we'll bring down the 2. Okay, almost done. What times x gives you 7x? 7. So 7 times x, 7x. 7 times minus 2, minus 14. Subtract the quantity. Okay. Instead of subtracting, add the opposites.
14 minus 7 is 7.
So 7's canceled. 2 plus 14, 16.
16.
There's no more stuff for us to bring down. There's also nothing I can multiply x by to get 16, right? I can't do something times x to get us just a 16. Right? So that's a remainder. And so what do we do with the remainder? We bring it up here, and we add it on to the end. It'll be 16 over the x minus 2. And there's our final answer. Okay. There it is. Okay. I want to show you just one more thing here, but I won't do the whole thing. But I just want to show you the setup at least, okay? Because, you know, I want to do this too. Lindsay talked about synthetic division. If you guys heard I was talking about that. But synthetic division, you'll be able to use that for a problem like this, okay? So in other words, I will show you another method that's faster than this to do this problem. You can choose to use that if you want to. So you might wonder, Ms. Whitmire, why are we even bothering about long division if there's another faster, better method? And well, it's because sometimes you have to use long division. And here's an example of a situation where you have to use long division. If I ask you to divide something like 3x to the 4th minus 5x to the 3rd plus 4x minus 6, and I ask you to divide it by something like this, x squared minus 5. Okay? The difference here, okay, and you'll see it when we talk about synthetic division in the future, because I can't really say Monday because it's not Monday, but who knows what it'll be. When you divide by a linear, a degree 1 polynomial, you can use synthetic division. When you divide by a quadratic, a degree 2 polynomial, you have to use long division. So let me show you the setup, and then we'll stop. Okay? So, what goes outside in front here? Yes, x to the second minus 5. But be careful. I am missing a term in here, aren't I? What term am I missing? I don't have what term? I have an x squared, I have minus 5, but what's missing between those two? And what's that? Yeah, well, we're missing, like, there's no x term, right? There's an x term missing. So I'm going to put a plus 0x and then minus 5. So that's what I mean by a placeholder. Use 0 for missing terms. So we're missing an x term here, so I'm going to put a 0x in. This polynomial here is also missing a term. What is it missing? Yeah, 0x to the second. So we'll have to write it out as 3x to the 4th minus 5x to the 3rd plus a 0x to the second plus 4x minus 6. Okay, just like that. And then you would proceed as normal. You're going to use the x squared to guide you, and then you would just multiply by like 3x squared there, and then, you know, continue on. It'll be 3x to the 4th plus 0x to the 3rd minus 15x squared, and you subtract the quantity, and then go from there. Okay? Same idea, though. I'll leave that for you guys. Okay? Here's how that would actually work out. I'll put this on the video so you guys can at least see. There's how it is worked out. Okay? So, there will be a homework assignment I know, for 2 weeks, okay, you'll have Schoology. Oh, good. Email's down. Let me give that to you here real quick, though.
There is a homework assignment for these next 2 weeks.
Just for tonight, 6-4, okay, numbers 3 and 5, and 6-5. One more, Smith. 6-5, numbers 5, 6, and 12, and 7-1, number 2. I'll get you the page numbers here too.
That's just for tonight, is that correct?
Well, I mean, yes. I mean, yes.
What?
Let's see. This will also post in the Schoology, but I'll put it up here too. This is page 228. Check my notes here. Oh, of course. And then 6-5 is starting on page 237. And then 7-1 is page 252.
252?
Yep, 252.
That's the work that we gotta do. That's going to be all on Schoology.
Say what now?
How are we going to keep up with the rest of the work?
So, folks, so here's the deal. Check Schoology. We've already been using it, okay? So if we are expected to do work, I will be posting stuff to Schoology, okay? Feel free to message me and stuff like that if you need to, okay? But yeah, please check Schoology. I also have copies of the test review for you as well, so you can start kind of seeing what we're going to be looking to for the test. The test will probably be next week sometime, I want to say. Oh, well, sorry. The next week we're in school, I should say. Guys, you can back in the classroom, please. So here's the review. But of course, I don't know when the test is going to be, but these are,
I've gotten so much
I don't know.
What's the big deal with this? Like, why would you have to announce that? Who cares? We don't care about whoever did whatever. Why would you have to announce that? Who gives a fuck? I know.
Did I get you guys a review? Bobby, you need one, right?
Yes, sir. And then I can work on. But yeah, the Fortnite thing was unnecessary. We didn't need to know about that.
That was strange. Yeah, I don't know.
That was solely to point out a kid.
I guess
that was solely to call out someone.
It's one person.
My other question is,
Which there's no use for that.
if they expect you to post stuff for us to do, like if you post something on Schoology on Monday, it would be due Monday.
I will let you guys know when it's due and stuff like that too. Okay, I'll let you know the due dates.
I'm not great with Schoology, so I'm gonna have a rough time.
So please, guys, check your emails. Okay, don't just shut down. Check your emails. And if you need to be on Schoology, be on Schoology. Stuff might be getting graded, so just please be aware of that.
The good thing is, if we